Section 4.7, Factoring, a General Strategy. So this section is dedicated to knowing how to go about attacking factoring. Because we've learned so many techniques. This whole chapter, each section, has just about been a technique. So here's a quick outline to kind of help you guide you through this world of factoring. First, you always want to look for a common factor. Of course, everything divides one, but anything other than one. Or if there is a leading negative coefficient, for example, or just a number, or maybe a variable, or maybe both. Next, the number of terms you have is a big indicator as to how you will proceed. If there's two terms, you can try differences of squares, or you can try a sum or difference of cubes. That's another option. If there's three terms, a trinomial, determine the trinomial has a coefficient of 1 or another integer. If it's not 1, then you continue with the AC method if possible. If there's four terms in the polynomial, then you can try by grouping or removing a common binomial factor. And third, always factor completely. Sometimes it might take more than one factoring technique to fully factor. And you can always check your words by multiplying everything out. It should give you exactly what you started off with. So let's take a look at this first example. We have 118 y minus 27. Actually, that's a typo. It's supposed to be 18. 18y to the 9th power minus 27y to the 8th power. So here, I see that we can start off by dividing out a y. They can both be divided by a y, and you always pick the one that's smallest, a y to the 8th power. Is there a common number that divides both 27 and 18? Yeah, 9. So they can both be divided by 9. If we divide both of those terms by a 9y to the 8th power, we're left with 2y minus 3. And we have factored this problem. Next problem. I have y to the 6th power minus 1. Okay, so you have many options. Which one do you start off with? Whichever one you like, actually. So here I see a minus and two terms. So I'm thinking differences of squares. If you do, you want to think of a number that squared gives you m to the 6th power, and a number that squared gives you 1. So 1, and when you're working with exponents, think about dividing it by the exponent. So 6 divided by 2, we get 3, m to the 3rd power. So this factors to be m to the 3rd power minus 1, m to the 3rd power plus 1. Next problem, factor 4x squared minus 14x plus 12. You always want to think, is there any common factor that I can start off with? In this one, they can both be divided by 2. If we divide by 2, we're left with 2x squared minus 7x plus 6. That makes it a bit easier to factor my trinomial. So because my leading number is not 1, I have to use the AC method. So I want to think of two numbers that multiply. Well, I want to multiply my A and my C, and I want to think of two numbers that add to give you your middle term, B. So in this case, A times C, 2 times 6 is 12, and my middle term is negative 7. So what numbers multiply give me 12, but add up to give me 7? Well, 3 and 4 work, and they need to multiply and be a positive, so they both have to be negative. And when I add them, they're negative, so that works out. So let's replace that middle term with a negative 3x and a minus 4x. I need to expand to have 4 terms so that I have 2x squared minus 3x minus 4x plus 6. Then I proceed by grouping. I group my first two and my last two. For my first two, I can factor out x, and I'm left with x minus 3. For my last two, I can divide out a negative 2. Oh, I had a 2 in the front here. So that we have 2x minus 3. We see we have the same thing in the parentheses. So we have 2x minus 3, and then we're left with the x minus 4. And we bring down our initial factor because I need that. So when I multiply it all out, I get to my initial problem. Let's continue with this next problem. We have m squared minus 4b to the fourth power minus 14m plus 49. So when I take a look at this problem, it's kind of weird. If I group my first two and my last two, it doesn't fully factor to my benefit. So why don't we rearrange it so that I can try factoring? I guess this one is challenging. So I see m's. Why don't I rearrange it so that I have m squared plus 14m plus 49, and then we leave that minus 4b to the fourth power on the side. Let's focus on our first three terms. I can try to factor this. So what numbers multiply give you 49? That add to give you 14, 7 and 7. So that factors to be m plus 7 times m plus 7, or m plus 7 squared. Okay, so now I have m plus 7 squared minus 4b to the fourth power. Okay, can I factor this? Well, yeah, we can think of this as a difference of squares. So that I can think of this as something squared and this as something squared. So this is m plus 7, and that would be 2b squared. So this factors to be m plus 7 minus 2b squared, and m plus 7 plus 2b squared. Remember, it's those numbers with a plus and a minus. Oh, I wrote them backwards to match what I had written. Okay, so in this section, we're just bringing it all together. How do I identify and come up with and notice all these different factoring techniques? Here's a quick list, but regardless, always take your time. Don't be rushed. If you're rushed, you might overlook what type of problem you're working with. All right, that was section 4.7, factoring a general strategy. Thank you.